Thank you very much for coming. I feel obliged to notify you there's been COVID at this conference, so thanks you for braving and showing up in the same room. But if you feel comfortable, you have to mask up or join virtually. We are going to keep the doors open in the good old days of ventilation, see how that goes. But other than that, let's start the session, which is just 60 minutes long. That's easy 60 minutes. I think in the Earth space-time reference, probably 73, but we're not going to, we're going to say that out loud. So quickly, we are going to have 3 presentations. First, I'll be talking about cloud-optimized HDF5 files. That'll be followed by my coworker, John Reedy, talking about accessing HDF5 data in the cloud using highly scalable data service. And then we'll end up with Dana Robinson, who is the HDF Director of Engineering, and talking about the state of HDF and the latest developments in the processes and the HDF software. So I'll go first, and I will time myself because that's the best way to keep me on track. So I talked about this at the last ECIP summer meeting, and this is expanded in some ways from there. I tried to propagate this idea as much as possible, and I would really like you to help there, either by contacting me with your issues or information how everything that I'm going to talk about on these slides worked or didn't work, or basically saying to your colleagues that it's possible to create cloud-optimized HDF5 files, because it is. The only problem is that the files who were already created, it's kind of too late for them. But also the HDF5 library needs to be told to do some things that make HDF5 files cloud optimized, which is pretty much the same with GeoTIFF. You have to kind of convert them or do something when you create those GeoTIFF files. So I'm not going to, you're right, I'm controlling here. Yes, so I'm not going to talk those fancy, general files, because that's like everyone knows what cloud optimized file means. And we'll skip that so we have time for other things. So this is, why I kind of started thinking about how to produce cloud optimized HDF5 files. I wanted to find sort of a sweet spot where DEX or any other archive of HDF5 files will not have to reformat them every which way for every kind of use. But because also people download still HDF5 or netcdf4 files, that we get that type of configuration that will work for both types of users, both in the cloud and for those who download files and access them in the more traditional ways. And also HDF5 library now, which is already 25 years since, and Dana will mention that, it's like ECIP organization itself, has done a lot of effort to support all file format versions and all the storage features. So really use HDF5 library as much as possible. Avoid the reason to create another reader of HDF5 file format as much as possible, obviously. So what makes cloud optimized HDF5 files? These 3 things. First of all, and by far the most important one, is the large dataset chunks. I cannot stress this enough, because typically what happens with people who convert netcdf4 or HDF5 files into ZAR, they do generate bigger chunks. Well, you could start with bigger chunks when you create those files. And so that's the very, very important thing. How big? What in bytes? Well, that's again discussion point for various uses. But I think, again, think about users who are going to use these files in a file system. Probably going to 20, 50, 100 megabytes per chunk, it's probably too much. But that's other discussion. The other one is minimal use of variable length data types. And this is really important if you're really going to create a lot of variable length data. How you create variable length data, that's another story. One source of variable length data is netcdf strings, because netcdf4 encoding of netcdf strings actually creates variable length HDF5 strings. Luckily, USD's data, or most so far of geoscience data, doesn't have that many strings. So I think we're safe there, but this is something to think about when you do work and think about data types. And finally, consolidated internal file metadata. That's the equivalent of .z metadata, JSON. So once you do those three things, HDF5 files are pretty much as good as any ZAR store in terms of data access. And again, this is me. So about large data set chunk sizes, what I want to again explain, to be absolutely clear, there are chunk size and chunk shape. I'm talking about chunk size in bytes. Chunk shape is the number of elements in each dimension of the chunk. So let's keep those things separate. So essentially, chunk size is number of elements in the chunk times the bytes that each element requires to store. That gives you the chunk size in bytes. The Amazon best practices from what, 3-4 years ago now, basically says that if you need to do HTTP range get requests, probably within 8 to 16 megabytes range size. So I'm just giving these numbers. So once you think about chunk sizes and these optimal range get requests, you kind of do the math, how many chunks you eventually want to have in one range get request or something like that. But again, this is all just some kind of best practices advice. You have to tailor that to your own needs and data. Endemic. So why is this important to differentiate between chunk size and chunk shape? Is because chunk shape still will dictate how many chunks a certain data read will touch. And so you can have chunk sizes of the right size in bytes, but if the wrong chunk shape, then you're going to go through many chunks again. So that's why I want to make absolutely clear between chunk shape and chunk size. Little known thing, and that's the reason why so many best practices or instructions or Googling, Google web pages that have various advices. Default HDF5 library dataset chunk cache is 1 megabyte, and that's why we still produce chunks of 50 kilobytes or 16 kilobytes or 8 kilobytes or that kind of stuff. You really have to increase this dataset chunk cache even when you're writing the data, otherwise the write performance can suffer, but basically it's doable. The library allows you to do that, and then you just basically write out these things efficiently. What you again have to think about is how big you want to make these chunks, because again, if it's too big, then the compression, decompression, all that stuff is going to take too much time. How to set chunk cache? Sorry, yes?
How do you set a chunk size per data set? Chunk cache size?
Yes, there is a function for that. On this slide, the second one from HDF5 library, that function call will do that for each data set. You can do it for all the data sets in the file, like a global setting for everything in the file. That's the first one. For individual data sets, that's the second one. And I'm giving examples for HDF5 library, C API, giving H5Py, and I'm giving NetCDF library as well. So this is how you can do it and set up things for chunk cache sizes. Again, this is both writing data and reading data. Next, variable length data types. Yes, so this is the problem really with HDF5 file format. Because right now, the way how variable data is stored in HDF5 files is kind of not friendly for HTTP range GET requests. The problem that people in Kerchunk land faced was that they thought that there is a variable length data in chunks, and then they found some kind of weird pointers to somewhere else in the HDF5 file where the variable length data is. So that was like, what is this? How we deal with this? And so that's why I try to minimize the variable length data types. There are ways that we may solve this problem, but this is everything I'm saying right now is what you can do and achieve with the current HDF5 library. I'm not talking what might be possible eventually, or near or further future. And again, when I'm talking about variable length data types, I'm again talking about HDF5 datasets. Variable length attributes are fine because typically you get that data anyway, or you store this data in some other way, so it's not a problem to consume the attributes. But this is for data, so it means HDF5 datasets. Which HDF5 datasets are equivalent of ZAR arrays, which is equivalent to netcdf variables, just so everyone is clear. So consolidated internal file metadata. How am I doing? All right, well, not bad. So basically, this is the same idea that ZAR folks came up with this .z metadata JSON, and that means you get only one data read, and you get absolutely everything information about all the HDF5 attributes, where the chunks are, what are the groups, what are their names, everything. And obviously, it's very important whenever your application needs to really understand the file's content before doing any kind of actual data reading. And the reason why current files don't really work is because the library, by its own creation, always thought that writing small pieces of this internal file metadata throughout the file is a good thing, because that allowed applications to change, to modify, to come back and do other things for the duration of the application, the runtime. And we're now living in different times when that's really not useful in terms of the cloud applications. So you have to change the default behavior of the library. So how can that be achieved? So I have these three cases and I'm going through them listed here. Each one of them involves more of HDF5 library. So the first one is the best one if you actually want to use the library to read the data. And then slowly we're going second and third, where you're kind of moving more and more away from actually using the library for reading the data. So as you can see, the first one is create files with something. Well, that means that all the files currently in existence are kind of missed that opportunity. But there are some ways this can be fixed, and I'll show you how. So paged aggregation basically is called one of the file space management strategies. It's not the default, we covered that. Can only be done at file creation, obviously. It probably is best suited when you basically create file only once, read out the content, and then done with that file, right? In other words, you don't come back to modify the content, which I think is very, very common practice here. What that does to the HDF5 library means that the library will start writing out data in these file pages and of the size that you specify. And this is the important thing. Because when the library starts writing out these pages, it actually separates the internal file metadata in separate pages and all the data in, again, separate file pages. And so if you get the right size of these file pages, you will force the library to write all the internal file metadata in a single page, or few pages at the most, and be done with it. The other big benefit of the page aggregated files is because that allows, well, the library has a special cache of these pages. And so when you're reading the data, you can actually store these pages in that cache. Again, you can set the size of this cache, and that will help preventing the library to going and ask for more data and make those expensive S3 requests. So, you can do this page buffer cache pretty large, and you can kind of compute how many pages you want to have in this page buffer. On top of all of that, the library actually has the statistics to give you that you can look afterwards and actually get the results of how many times the cache will help you, how many times it needed to request new pages, and all that good stuff. So after trial runs, you can actually modify the page buffer cache size. But this is only available, again, if you have page aggregated files. So again, this is the best case for using HDF5 library to read the data. And these are now the calls for how to set these things up. I couldn't find in NetCDF library support for that. I may be wrong, but I Googled the source code and didn't come up with these functions. So I'm pretty sure that NetCDF library currently cannot allow that straight away. How to do it if you already have a file. This is the command line. H5REPEC is part of the command line tools that comes with the HDF5 library. And you say -s page, that means use the file space strategy that I just mentioned, and then .g, and then you do the byte size. And then usually you could put here 8 MB or 16 MB or something like that, whatever you want. And then you have input and output file, and the H5REPEC will generate a new file with these settings. This is the second of these methods to consolidate metadata. Here, you again have to create a file, but there are no more pages, and you lose this page buffer cache that I talked about. So this is, again, the way that you tell the library that store internal metadata in a single block in the file, and the library will do it. Obviously, the best recommended size of this is enough for the whole internal file metadata that there is in a file. But there are no more page buffer cache. Everything else is like before when it comes to HDF5 library behavior. And again, function calls, you can do it with the library, obviously. H5Py supports that, not NetCDF library. In case you already have a file, this is the command line. You do this, and the library will produce such a file. This is the way how you actually find what's this internal file metadata size. You run h5stat, another command line tool on a file. One of these things is going to give you the file metadata. This is the magic number. Of course, you don't have to tailor these numbers for each file. I would recommend you sort of go with 16 MB or something, and then, you know, just fabricate those files as needed. So the final approach is basically none of these creation properties are used. You basically create a file as is right now. Obviously, do the dataset chunk sizes correctly, because that's sort of a separate issue from all this consolidated metadata. And then at the end, you basically create a user block. This is the block of bytes that the HDF5 library completely skips when dealing with the file. So this is, for example, the way how JPSS, or whatever is now called it, NOAA, was stuffing metadata in the file, in the HDF5 files. These are the bytes that the library leaves to the user application, whatever content to put there. So the idea here is basically that you create a file, create a user block of NME bytes, run whatever you need to run to collect the information about the file content, and then stuff that content in whatever format you want into the user block. So at this point, you are kind of completely independent of the library now. The consolidated metadata lives again with the file, so it's still single object, nothing to lose, nothing to track separately. But from there, you just get those first, I don't know how many bytes, you read them, you process them, and off you start reading from the HDF5 file like before. So that's that. How I'm doing, oh, close. And so this is how to set up these things. Again, I haven't found a way to do it with the NetCDF library immediately. And this is how to actually achieve, again, on currently existing files. Either H5REPEC or H5Gem. I discovered, doing this work, I discovered a bug, it's undocumented feature in the HDF5 library that if you are doing the dataset, you know, chunk file locations, the library will not take into account the user block. So it's going to give you locations like the user block doesn't exist. So you kind of have to, you know, add those bytes manually. I don't know if that's going to be fixed in some release or not, but so far at least we know. And I'm hoping that it's going to be in documentation so people are understanding. But that's the situation, yes.
Okay.
Yep.
So does that mean that any file file, any current file that has a user block would not work with Kerchunk?
Yes.
And you need to add a constant.
Well, someone, maybe I will need to Kerchunk and add that, yes. But yes, currently that's the, and yes, it is. Oh, there's another geeky stuff, but that's not cloud optimized. So anyway, so the wrap up thing, as I said, HDF5 library, if it's instructed, can create cloud optimized files. Definitely larger dataset chunk sizes. By now, you probably understand this is the most important thing if you want to create cloud optimized files. Consolidated internal metadata is also a very important part, but not, not always, especially if you, for example, use this user block idea. And again, consolidated internal metadata and dataset chunk sizes are really two different things. So one or the other are really solving different problems. Both, again, make everything much, much better. Page aggregated files, as I mentioned, use only, really recommended if you're going to use HDF5 library to read the data. We, from our experience, recommend DMR++ as a representation of file content to stuff into the user block. I think it's much more accurate representation of the file than Kerchunk JSON. So I think it's worthwhile keeping with the file. And obviously, cloud optimize these HDF5 files as much as possible before they leave you and go into the object store. Because then what you need to do is copying them from the object store, bring back to some file system, and then do all this work. And that is, I think, thank you, yes. So any questions? James? Is it here? Oh.
Hey, thanks. So yeah, so when people are ingesting data in a workflow, could they modify those workflows, like add a cumulus task, for example, to do some of that reformatting? Some of the code you showed earlier, you had those one-line commands. If they've got existing HDF5 files that are produced by other components in a workflow, can they modify the workflows using what you showed to produce cloud optimized before it gets moved to S3?
I think they could. That's how I took the sample files and generated these versions of cloud optimized files. I use the H5 repick and that kind of stuff.
So it would be no more complicated than doing that.
No more complicated, yes.
Cool.
What you're talking about, James, just to make sure I understand, is if you have a bunch of files somewhere in a file system and you want to migrate them to the cloud, which is going to take some time anyway, you might as well just run these repacks on the way. Yeah, right. And then you have your initial disk optimized HDF files at home, and you have your cloud optimized files in the cloud. Yeah. Thanks.
Yes, Rama.
On the page aggregation, are they integer number of pages that get aggregated into a single page? Is that the way it works?
Sorry.
So if you have pages that are of size, let's say 100 bytes each, and you want to aggregate them, and you aggregate 100 of them together, it becomes a 10,000 byte page, as opposed to selecting some 950 byte pages like that. Is that correct? So the integer number of pages need to be aggregated together.
Well, no, basically when you do the page aggregated file, the library starts writing out data or whatever into that page, and then when something arrives that's bigger, it creates another page. So page aggregation does incur a certain amount of free bytes in the file that are unused. per each page. So it will generate a larger file.
Okay.
But again, I tried with some ideas, it's less than 1%. So I think it's kind of doable.
So Alex, this term page is actually a term that I haven't used or haven't heard in the discussion of HDF. So a page is basically just some section of the file that's managed by the library. Is that right?
Well, we have director of engineering, he can correct me, but I think that's the case. Dana, you want to?
A page is just it's like a page in memory. It's some block that's in the file at some, and the library manages all or anytime you have the setting, it just manages those sort of blocks within. So it's sort of like a chunk, but sort of different.
Well, I mean, you heard
Oh.
it here first, but a page with data in HDF5 file looks awfully similar like a ZAR shard with chunks in it, but you didn't hear it from here.
Like a
So-
chunk has like a shape and stuff, and a page is just, it's like a page in memory, right? It's a linear address chunk, yeah. Yep.
Yeah.
The whole point is to reduce the amount of times that you have to go to the S3 bucket, right? And so now you go once, you go twice, depending on how you have your things allocated, and now it's in the cache, and so now everything's fast because it's local. So
I'm seeing some activity on chat. Is anyone
Yeah.
checking chat, or I should?
We
do that?
had some questions in chat.
So
before
how
I started
we
running
just
around.
asked people from the chat land ask?
We can.
to go
Let's
and
see,
unmute.
I can just start doing them in order. How does this effort compare with the NetCDF4 as ZAR work going on? It's the first one.
Let me see how this compares.
Yeah. Maybe just click it over. Scroll up.
Can this be linked in the notes? The slides are not yet officially approved by NASA and Raytheon, so I'm asked not to post them. But whenever that happens, I will do it. So how does this effort compare with the NetCDF4 as ZAR work going on? Well, I don't know what NetCDF as ZAR. I mean, you mean like reformatting into ZAR, or because essentially what this effort would help with is that effectively producing NetCDF4 files with this kind of features would then both enable producing Kerchunk sidecar files much faster if those files are in the cloud store already, and also allow, because there's a bigger chunk sizes, that essentially performance is exactly the same. I mean, I created something that out of which came Kerchunk, and when I enriched signal from USGS, when both of us kind of compared a ZAR store and a NetCDF4 file with exactly equivalent storage settings, compression, chunk sizes, and everything in a cloud workflow with Xarray, statistically, it was exactly the same performance. There was no difference going to ZAR store or going to such a NetCDF4 file. So I guess that answers that question. The next question is, would you please explain the difference between chunk size and chunk cache size? When does each become relevant in user? Well, the chunk size is something that's in the file. And once you set it, obviously follows you throughout the lifetime of that file, unless you, again, create another version of the file with different chunk size. The chunk cache size is the runtime configuration of the HDF5 library. And so every time you run it, either for writing or reading, you can set a different chunk cache size. That's the difference. Hopefully answered that. Next one, how significant will each of these options, like metadata, page sizes, have on accessing HDF data in the cloud? Have the significance been quantified in some way? Yes, I did quantify it in some way, and I have some slides, but there is no time because this is an hour-long session. But I can give you an example. When I had this example of the ISET2 ATL03 file, it took 155 seconds to scan the file for its content, for groups, attributes, chunks, files, locations, everything that, for example, Kerchunk would need to get, to work. When I put this cloud optimized file with 8 MB of a page size, it took 1.1 second. So, you know, it's about 155 times faster. For many of the strategies presented, there is currently no support in the NetCDF API. Does this mean NetCDF4 data can't be cloud optimized as well as HDF5 data? No, it can be cloud optimized. Again, right now the H5 RePack will do, because H5 RePack doesn't really care about NetCDF4 or HDF5 file. It's all HDF5 to them, to the tool. So, but you cannot generate immediately from NetCDF library, as far as I understand now, these cloud optimized NetCDF4 files. Yeah, should be. Well, if it's page aggregated, then the library NetCDF would have to allow setting opening. You have to tell to the library you are opening a page aggregated file. So yeah, so yes, right now page aggregation is a complicated thing in NetCDF library. Yes. But H5Py works, which means that H5 NetCDF should be working, which means that Xarray using H5 NetCDF as the backend engine would work. So, you know, it's easy. How does one choose the chunk sizes for files? Well, that's a whole, you know, we have a whole conference on that. Yeah, sorry.
Sorry. Are you saying that when you open a file, you have to tell it that it's a page? It doesn't,
Yes.
can't just tell from reading,
Yes.
opening the file?
Yes.
So
That's something that I want to change in the HDF5 library, but it's not
Right.
yet possible. Yes.
okay, so if you have code that opens a file and doesn't tell it that it's a page aggregated file, which how
It'll
will
fail.
it know if it's a page aggregated file anyway?
Yes. It'll fail.
It'll fail.
Yeah.
Interesting. Okay.
No, that's true. So we are opening
Is that
up
a
some
feature?
workflows that, you know, but that's currently the you know, the one of the complications with HDF5 library. I wish that was a simpler thing, but you know. So that's that. And there is some link to the blog, cloud optimized formats. All right, next steps. Yeah, so great, thank you. I think I'm done. Oh, if you use the H5 RePack to massage or CF compatible, will the output still be a good C? Yes, it will be. So I think I answered all the questions. Thanks. Yes, thank you. So, all right. So the next one is John Reedy. And I will stop sharing. Yeah, stop sharing this.
Yeah, perfect.
And I'll leave my meeting so I can walk away. And then John should host. You know, John should run it from his computer.
Oh, as well?
I think, John, can you
Oh,
make
sharing,
him share?
that's right,
Okay.
that's
Yeah.
Yeah, oh, let me make him a co-host.
All right. So,
You guys hear me?
yes, we hear you.
Should I be sharing my screen or,
Yeah, you should be able to now.
okay, let me do that.
So for everyone, John is floating somewhere in Europe. Where are you, John, now? On a boat
On a boat near Estonia.
near Estonia. So if he gets basically some Russian submarine hit him or something, I have his slides. Continue.
Yes, I narrowly avoided Kaliningrad.
Or if another pipeline blows up, I mean, he's the guy you need to talk to about that. So I'm just saying. So go ahead, John.
All right, thanks. Oops, sorry. Okay, hey guys, so I'm going to talk about using HSDS, the highly scalable data service, to access traditional HDF5 files in the cloud. So I'll talk a brief overview of HSDS. Some of these topics, we dive more detailed into HSDS in prior ESIP talks, but I'll kind of skim over HSDS and then talk about how do you import HDF5 files into HSDS, a case study, and some conclusions. Oops. So, you know, the thing about HDF5, it's been around for some time. And when it was developed, the cloud wasn't really a thing. And so naturally, not everything about a library was developed with the cloud in mind. And so these are some of the issues that you have in using the library to read HDF5 files in the cloud. When we talk about a cloud, we're almost always, in the context of HDF5 at least, talking about either AWS S3 or equivalent things like Azure Blob Storage or Google Cloud Store. Of course, there are other ways to store data in the cloud, but only S3 has this low cost and universal availability that most people want for their data stores. So when you try to read HDF5 data in S3, the problem is the library is designed assuming POSIX compatibility and low latency. You have a set of operations that need to read from storage. This latency, the extra latency you have S3 kind of adds up and inhibits your performance. So S3 actually can be very high throughput, but not if you're doing a bunch of sequential reads from S3. So this bullet, your best performance is typically with 16 in-flight requests at one time, using relative large sizes, right? That's why Alexander was talking about the importance of having a large chunk size. So given all this, that led us to develop a new paradigm for storing HDF data, but not in the HDF5 file format. DIA is a sharded data store. We take each object, each HDF5 object, the data sets, the groups, the links, we store that as JSON in S3. And each chunk of each data set is also stored as an object in S3. So we have one HDF5 file becomes potentially millions of smaller S3 objects. Okay, so here's a representation of a data set. The dark lines are the chunks, and each of these chunks gets stored as a separate S3 binary object. If you looked at it in S3, you see something like this, where you have a root object, group JSONs, data set JSONs, and then the chunks are stored in this format where it's like 0_0, meaning the top left chunk of a 2D data set. Our 0_0_2 would be the second chunk of a 3D data set. So you could actually read and write in the schema directly, but it's much more convenient to use something we've already created, namely the Highly Scalable Data Service, or HSDS. It's a REST-based service for HDF data. There are serverless ways to access the same data, but I'll go into it. Of different storage formats in either Docker or Kubernetes. The scalable aspect comes from this idea that you have, you can run any number of nodes, either on one server or a cluster of computers. And we have two flavors of nodes. There's these blue nodes called service nodes and green nodes called data nodes. The sharded data store is over here on the right, and there's this virtual partitioning of the object store. And the idea is that each data node owns one partition of the object store. And this means that for any particular object, either metadata or a chunk, it lives in a particular partition owned by a particular data node. So when a client does a request, say to read a selection from a data set, that request lands in a service node. The service node will determine which data node or data nodes are needed to read those chunks, dispatch requests to those data nodes, the data nodes read the chunks, get their data back to the service node puts it back all together and returns that result to the client. One advantage here, Alexander was talking about the chunk cache size. With HSDS, you actually have a phenomenally large chunk cache that could be in the gigabytes of size. And it's a chunk cache that's persistent and is shared among all clients. So if you have a large enough chunk cache, frequently you can have your entire working set of data will be in the cache and be served at memory speeds. These are some different platforms we support and different storage systems. So you have HSDS, you have this sharded schema. How do you access it? Well, you could directly use REST API. Say if you wanted to create a dynamic web page. And that works with any language. And it supports parallel and asynchronous actions. Alternatively, if you're a Python person, you can use H5PyD, which is a Python package that emulates the H5Py API. One slight downside with H5PyD is that it doesn't support natively parallel or asynchronous operations. And finally, primarily for C or C++ users, you can use the HDF5 library with the RESTful. So the RESTful is a plugin for a library, and what it does is that it intercepts all API calls and makes equivalent HDF REST calls to the server. So your applications work just before, except now they're going through the server. And there actually is a parallel operation support just recently added for the H5D read-write multi-call. There are a bunch of command line tools that let you do things like list contents, get information about the server, and so on. And one thing I'll note is that data is round trippable. So if we start with an HDF5 file, you can run this hsload tool that loads it to HSDS store. You could then run hsget, which would get that HSDS store data and recombine it into your HDF5 file on your local machine. And what you get is not byte for byte identical, but it's equivalent to your original file. So if you want to have, if you have, say, some HDF5 files and you want to access them with HSDS, one thing you do is run hsload. And that will transcode the file, upload to the server in this sharded format. So it's kind of like repack, but you're repacking from your local machine to the cloud. The amount of storage to original file. And by the way, you can have aggregate 1 gigabyte files to make a 1 terabyte HSDS file. So if you have a lot of data, you may not want to have to duplicate all that data. So there's an option called --link. So with --link, what we do is just copy the metadata of the file. And that just typically comprises 1% or less of the file size. The chunks of the original file are now kept as pointers in the HSDS metadata. So whenever a chunk is read, it goes out to the original file, hopefully also in S3, and it retrieves that piece of chunk. And from then on, it processes like it would normally. There's another option called hsload --fastlink, which works like --link, except that these chunk locations are determined. So that makes it a little bit faster if you have a data set with lots and lots of chunks. You don't have to index those at hsload time. They can be indexed later. So these are some options. And now I want to kind of transition to looking at a case study. So we looked at the NASA ISAT-2 data set. And this is a NASA mission that collects elevation measurements. And one thing about it, we talked about the importance of large chunk size. The ISAT-2 file have a fairly small chunk size, 80 kilobytes. Now you could say, well, why don't I just repack all those files? Well, if you have petabytes of files, it may not be practical to have the storage and computational load to do all that reorganizing. So this kind of argument for just using what you have and making the best of it. So we're going to look at some ways where we can actually get around the small chunk size in these files using HSDS. So let me get on to that. So the idea is that a data node would get a request to read. Oops, sorry, I skipped the page. So for our latest version of HSDS, we added this hyperchunking feature. The idea of hyperchunking is that we form a larger chunk out of a group of neighboring smaller chunks without actually modifying the source file. So let's say your HDF5 data set, your chunk size is 40 kilobytes. We can create an HSDS chunk out of 100 of those HDF5 chunks. And that means that when a request goes, only has to deal with the smaller chunks, not all the microscopically small chunks in the source file. So how does this work? So the DN hyperchunk, but that's actually composed of multiple HDF5 chunks. So you think we could reduce again to the case of having to do many, many small reads to S3. But it turns out that oftentimes in the HDF5 file, the chunks are adjacent to each other, are nearly adjacent. And in this case, we can organize our S3 access to read a bunch of chunks all at once. If we can't do that, HSDS will read the chunks asynchronously. So in practice, what happens is that a request that would need, say, 200 chunks would only need 2 or 3 S3 requests, and those could be done in parallel. So how does this work in practice? Well, we created a benchmark for both Python and C. Here's a link to the Python benchmark. And we looked at performance using a variety of different methodologies, right? One is a local file on SSD drive, file on S3 using the ROS3 VFD, on S3 using a Python package called S3FS, and using HSDS. Results we got were, not surprisingly, the local file that was 0.7 seconds, which is great if you have local files. ROS3 took 0.7 seconds. Different HSDS. Okay, this HSDS native, where we didn't do linking, we just transcoded all the data to the sharded format, took 19.3 seconds. So about half the time of the S3FS. And then with linking, it took quite a bit longer. And we still need to kind of deep dive and figure out what's taking extra time. There is a bit of an extra hop when you have to link from the HSDS data sharded.
Well, As you can see, either Baltic Sea is too choppy and his satellite dishes missed the satellite, or something happened to the boat. I'm just guessing. So I was asked to pick up here, but I think we're close. So before the results, I think there's only one more slide, but I don't know if we should stop sharing and switch to the local ones. Where is the local ones? Oh, here? Yes? Okay.
Hello?
Oh, hey,
You thought I lost me.
we talked a lot of other things, but yeah, okay, it's okay.
Okay, anyway, let's finish this conclusions. So the property is not as good as HDF5.
You have to share the screen again. Yeah, it's probably. Yeah, I think there's only, yes, conclusion. So after results, there's conclusion. And so that's that. So any questions? Well, there's more acknowledgement and questions. Yes. So yeah. Hey, for John.
I'll say something, actually.
Go
the
for
fellow. So I'm a PhD student, and I use ISET2 data, and this use case really helped me, actually. I remember when I was writing code to like crawl through, like download the HDF5 files and crawl through them. And the scope of my analysis completely changed once, I had access to projects like Slide Rule and things like that utilize this. So cheers, basically, yeah.
Thank you. By the way, slide rule is actually at the backend now using HSDS. There's a NASA
okay.
Access project that John is working on.
Oh,
so
HSDS. Cool. Very cool.
So what he's reporting and doing is essentially part of that effort.
Yeah, it's been great.
Yeah. Okay. Next one is Dana Robinson, who is Director of Engineering at HDA Group. So he can answer a lot more detailed questions about the library and all that stuff. And Dana.
Is this true? I've only got 9 minutes left.
No, go for it. I said 73 minutes in our meeting. No, well, yeah.
It's the aerial time.
This is you, yeah. Just share the screen. Moving fast.
John joined us.
Okay, so first, so hi, I'm Dana Robinson. I'm Director of Engineering, Software Engineering at the HDF Group. The first thing I want to talk about is some stuff from Alexander's talk. So we'll try to fix that issue with the chunk offsets and the user block for 114.2, which will come out later this year. And then the other thing is the reading a file that has the page buffering switched on. Page aggregation files. Yeah, we should look at that because we store that in the super block. And so if that's not working, then that's a bug in the library, and we should fix that because the library shouldn't care. Once it actually opens up a file, it doesn't matter how the metadata got there. It's just looking for different file offsets in the file. And so if there's something, maybe it's a problem if you open the file up and then you try to write to it and you didn't have the settings the same, that maybe there's some issues there. But for reading, I'd be surprised if that's not working, but that could be a bug in the library. Yeah. So we'll look at this and we'll make, because that should not be a problem for opening up files. NetCDF should be able to open those things. And if it's not, we'll fix that and we'll get that maybe not into 114.2, maybe that's 114.3. But so anyway, so this is a quick overview of the state of HDF. We'll talk about us as a company, just really quickly, talk about the software status of our various HDF products that we have. Some of the current focuses that we have, and then just a quick slide on how we can help each other. So about us, we are a small company, right? We're about 25 people. We're a nonprofit. We're located in Champaign, Illinois. We were spun off from the NCSA in 2006. So we actually we curate this as a company. It's not just a a project that hangs out in space and then just a bunch of people work on it in their spare time. Like, we are organized around supporting the HDF products. We're a mission-driven organization. As we're a nonprofit, we're not here to make a whole bunch of money. We're to make sure that HDF products stay viable and your data are accessible for the long term. But that's what we do, is we maintain products, we do consulting, we do support contracts, we do training and things like that. I'll talk about that at the end. So one of the things to note is that HDF5 is 25 years old this year. So it came out in 1998. And so now we're trying to figure out what we're going to do for the next 25 years. We plan to keep our stuff around for long term. So we have a forum post that I created asking, like, what do people want to see in HDF5 2.0? Because after 25 years, it's probably time to rethink some of the assumptions, because it's a very different world today than it was in 1998. So some of our assumptions may not be valid, and we want to revisit a lot of these things. Not to fundamentally change how HDF5, the data model, works and stuff like that, but just things like the stuff about like the API and things like that. So the software status. So we'll go over HDF5, HDF4, HDFU, not so much HSDS. I usually let John talk about that stuff. So for HDF5, this is the release schedule. You can get to this off of GitHub. I always keep this up to date. The latest version is 1.14.1 that came out in May 2023. We're retiring all the other maintenance branches. 1.8 was retired at the beginning of the year. 1.10 and 1.12 will be retired later this year when we release those in the fall. I haven't scheduled out to 2024 yet. I assume there'll be 1.14.3 that will release sometime early in 2024. And that'll just be driven by the features. So when 1.14.0 came out, that had all the stuff that I talked about the last time I was at ESIP, the multi-data set IO, selection IO, subfiling, the Onion BFD. Those are all things that I've talked about at other talks. I won't belabor those here because we're short on time. 1.14.1, which just released, it's a maintenance release that has bug fixes, minor features, and things in it. 1.14.2 should have hopefully that bug fix for the chunk offsets. We've made some improvements to the read-only S3 VFD, so there's better logging in it. We now allow temporary AWS security credentials, and we're hoping to get it CVE free. So we have, there's been several CVEs that have been filed against the library. We've been going through and fixing a lot of those. We spent a lot of time over the last year hardening the file IO layer to where we read metadata, and that fixes a lot of the CVE bugs. We still have 3 that are outstanding, and I hope to have those fixed in the next couple of weeks, and then we'll have CVE free releases for 1.10, 1.12, and the next version of 1.14. So for HDF4, the latest version is 4.2.16-2. That's a patch release. We released 4.2.16 back in March, and then there was a Java bug that we had to do a patch release for it. But we also threw in some other small bug fixes, and I made some build system improvements. And the newsletter link is at the bottom. And one of the things I noticed when I was going through it, so in 4.2.16, one of the things that I did was I went into the library and I fixed all the hard-coded configuration stuff, because people are getting upset that HDF4 didn't work on the Apple Silicon. And so I went through and I changed it all to get those values that it needed from the configure options and stuff. And as I noticed as I was going through it, there's a lot of stuff in there that was not a great idea. And so I do want to make that library more maintainable and fix a lot of bad ideas that are old. And so there's discussion pages on GitHub, and I've put stuff in there. So if you use HDF4, if you care about this stuff, and especially if you care about Fortran, because the Fortran layer has some problems, there's things in there. Please comment and talk to us. I don't want to break things. I tried to be fairly conservative about 4.2.16 because I didn't want anybody to send me angry email, but there are things in there that I do want to address. And so one of the things that I'm trying to do is have a change policy to make it more clear when we're going to change things that might affect our users in ways that could break their software, their build processes, and things like that. And as always, we try to maintain API compatibility. For like HDF5, you can build the HDF5 library to have any API you want. You can have a 1.6 API, 1.8 API, 1.10, 1.12. You can pick that at build time, and then we will build the software so that it as far as you're concerned, it looks like the old versions of the library. And as far as file formats are concerned, we're very committed to forward and backward compatibility. So you should be able to always be able to create files in earlier formats for compatibility with earlier software. You should always be able to read earlier file formats. But there's other things where there's build system changes that we want to make. Sometimes there are things like changing semantics or changing command line options and tools and just things like that we want to be. And even when we're going to make breaking changes, we want to announce these to the community so people know how the libraries are going to change as we bump the versions and stuff. And we will actually move for HDF5 2.0. We will move to full semantic versioning, so people will stop yelling at us about that, because the one version needs to tick up at some point. So before we implement a breaking change, we will create a discussion post on GitHub in the repository. We'll create a post in the HDF forum. We'll make announcements in the newsletter. We'll try to be as noisy as possible about these changes so that people are alerted about it. And if we know that there are certain people and communities that require things, we'll try to contact you. No guarantees there, right? I don't always know who my customers are because it's open source. So, and we'll allow at least 30 days for comments, usually a lot longer, because it takes a while for us to get around to doing the actual work, and we go for a while between releases, but we'll try to at least allow 30 days. So that there's plenty of time for people to go on there and comment. And there's a link on there to the HDF4 procedure. I'm kind of baiting this in HDF4, and because we have some changes that we really do need to make there, and then we'll bring it to HDF5 and HDFU. For HDFU, the latest version is HDFU 3.3.0. That was released in April. We'll have a new version that will be coming out soon because of the patch release of HDF4. This is based on HDF5 1.14 and HDF4 4.2.16. All the older versions that were based on HDF5 1.10 and 1.12, we retired all those. So there'll just be, HDFU will only target the current version of HDF5 and HDF4 going forward. You could build it with older stuff if you wanted to, but those are the released binaries that we'll have. The releases are, yeah, like I said, those have been released. I'm retired, and we're looking to modernize or replace HDFU because it's getting a little long in the tooth, and so we'd like to modernize it and make it to be a nicer tool. So what are our current focuses? So the last year, we spent a lot of time working on stuff for the exascale computing project. And so now what I'm doing this year is kind of getting us ready to start to move the library forward in maybe some new directions. And a part of this is really just it's improving software quality. It's also about community building and increasing transparency, and then modernizing our HDF products. So as you can see, these are busy repositories. This is from the GitHub statistics. You can go look at this and you can see like how many commits we have in a certain period of time. And HDF5 is very busy, HDF4 not so much, but you can see where I fixed a lot of stuff in the library. HDFU, not so much, but these are busy repositories. There's a lot of development activity that goes on with these things. So as far as quality, again, we have the CVE repository that has proof of concept files that we've created so we can run a script over any version of the library, and you can see which CVEs affect that version of the library. And right now I'm busy compiling some tables of everything, and we'll deploy these to the maintenance branches so you'll be able to see for like 110, 0, 110.1, 110.2, which versions are affected by which CVEs. People are starting to take security much more seriously than they did several years ago. So we wanted to make this a priority. And we also have a posted security policy now. People can report bugs against the library anonymous, like in a private way, so that we can see stuff earlier. So we've been making a lot of changing there. Also, we're trying to make a lot of testing improvements. We're trying to do a lot more integration testing with key products like H5 with HDF EOS, with NetCDF, to make sure that as stuff comes in the library, nothing breaks as we update the library. And again, this is all about transparency, showing people that everything works. We'll have stuff that we don't test on GitHub eventually through public CDAsh that'll be linked off of the main repository, so people will see that, where we test on like the various HPC systems. And we're working very hard to resolve all these unfixed GitHub issues that we've kind of accumulated over the years, and also just code cleanup in general. And transparency. So HDF5 kind of grew up in a walled garden where it was inside the HDF group for a long time. There was no access to like our subversion server. There was little access to our subversion servers. Bitbucket was kind of hidden behind a wall. And so now we're trying to change this mindset to where everything is really done out in the open. So I'm moving more and more of the project managed to GitHub. And this is difficult because GitHub's project management stuff is not as good as Jira, but we're trying our best to try to move as much as possible out in the public and do everything in full view of everyone so that everybody can participate and also just kind of see where the library is going. So we have this HDF5 working group meeting. If anybody's interested, it's every Thursday at 10:05 Central Time. If you want an invite, it's Teams. Send me email and I'll send you an invite. It's for people of all technical levels. It often talks about very low-level things on the library. This is where we go over pull requests and things like that and look at all the new issues and have tech discussions. But if you're interested in what we do at the library, or if you have the things that you want to discuss about the library, then please pop in and join. Like I said, we're moving all of our project planning to GitHub, and we're trying to do more testing via GitHub Actions and not on stuff that is hidden inside on some server that's inside of our firewall. So about building community, we have the aforementioned HDF5 working group meeting, but all of the stuff in the transparency slides. We're starting to try to add more people in as code owners. So people who are outside the company, we welcome other people's expertise. Even if you don't know as much about the specific innards of the library, it's nice to have people who are interested in HDF5 and are language lawyers and really know a lot about the C standards and POSIX standards and things like that. It's good to get those people's input on when we're trying to make decisions about what we do with the library code. And we're spending a lot more time trying to connect with our users, both new and old. That's just why I'm here at this meeting, to talk to people. So our software, as I mentioned in the slide, where we're 25 years old for HDF5, some of our software has been around for a long time. HDF4 is 35 years old, came out in 1988. HDF5, 25 years old. HDFView is 16 years old. And so we try to keep our software up to date, but the code is still older and could use an overhaul. So we're trying to spend some time this year having better support for new compilers, especially Intel's One API, which has become extremely popular. It has some interesting quirks and features that we have to engineer around. Better support for things like AI, machine learning workflows, better cloud integrations. We've seen the read-only S3 VFD work that we've been doing, cloud optimized file work, better support for heterogeneous computing and GPUs and things like that. Windows Unicode support is kind of high on my list. I know a lot of people use Windows, and that's important for things like desktop instruments. Better variable length support, multi-threading, support for sparse data, improving performance, and just internal cleanup and refactoring and cleaning up a lot of the structures inside the library that are over-engineered, and that we thought that we would need this bigger system, and now we can bring this stuff down to smaller things and just make it easier to work inside the library. And note that some of this stuff is not necessarily things that are going to be done just by our group. Like I said, we're trying to build a bigger community, and so some of these things like multi-threading and support for sparse data are being done by companies that are outside of the HDF group. So these are other people that are working to improve the library. And so I would like for us to have a much more robust open source ecosystem organized around HDF5. So how can we help each other? So basically what you guys get for us for free, for $0, you get help desk support, you get us working on sustaining the library, keeping things up to date, keep making sure it still works with different compilers. You get these HDF clinic meetings that we have, the working group meeting, we have webinars, we have user events, we maintain the forums, we do community outreach, and we make sure that your data are going to be accessible for the long term. But that is, even though the software is free, it's not free. It costs money to keep the lights on at the HDF group. And so, and also too, we require people's time and expertise. And so ways that you can help us is become a code owner. So if you're really interested, again, in the library, let me know, talk to me. Consult with us. You can purchase custom development if you need features. We do priority support. You can donate, become a sponsor, collaborate with us on proposals. We're more than happy to go in with people on research grants and just become an HDF advocate. And so there's contact information on there. You can talk to me if you'd like to work with us. We have some user groups coming up. The US HDF user group meeting is going to be August 16th to 18th at The Ohio State University. There's a link on there if you want to go check that out. Then there's the European HDF user group, where we're going to have a focus on compression and plugins, and that's going to be in September, and that'll be at Daisy in Hamburg in Germany. So thanks for your time. And this is Roberto Raytheon. Questions?
Yeah, so any questions?
Yes.
You mentioned that one way you're trying to modernize the application is by moving things to the cloud, moving things online, making everything a lot more open source. For the application itself and the user interface, do you have any plans that you haven't already mentioned?
What do you mean, like for user interface and like HDFU?
Right, just for the application itself, do you have any big plans for that at this point in time, or are you still playing around with that?
No, we're still trying to, so I have the post up there for HDF5 2.0. There's a lot of ideas up there, but we haven't settled on exactly what we're gonna focus on just yet. So that's still a work in progress. Yes?
Where's the mic? Where's the mic?
Oh.
I was just wondering if there's any thinking about the HDF5 file format spec and kind of publicizing that it's available and out there somewhere a little more.
It is out there.
Yeah.
Yeah, all of our,
It's-
one of the things that we've done in the past year or so has been to move all of our, as much as possible, our documentation to Doxygen, and that includes the file format spec.
Yeah, I guess I've heard some pushback in some circles on HDF5 and NetCDF4 because there's only one library implementation. There's, the specification hasn't been, thoroughly reviewed by a second implementation, I guess, basically. I'm just wondering if you've thought any about pushing that a little further, trying to, advertise that it's there and encourage other implementations. I don't even know how to do that, but yeah. So in the NetCDF Java library reads HDF5 with not through the C library, but I think that's limited in some ways. So anyway, I'm just thinking about how that might,
Excuse me.
if that would help the growth of the community to have a multiple implementations and.
I would love to see that, but the file format is complicated, right? Like things like the fractal heap and stuff like that are kind of non-trivial to implement.
Yeah.
But I would love to see it.
Okay. Yeah, that's about how I feel too.
Yeah.
Okay. Thanks.
I mean, I will answer the question. So there is no barriers to someone doing it. Well, I mean, barriers as, how they can do it, maybe. But I mean, there is no, no one is going to say don't do it or prevent from.
Yeah, no, I was kidding. Yeah, barriers in that it's complicated and that it takes a lot of work. And I mean,
Yeah.
that's why
Right.
the
And if
NetCDF
someone-
Java isn't complete or anything, because it's just a lot of work. And yeah.
Right. If someone were to actually try to do that, we'd be thrilled to help them out. If somebody wanted to create one in Rust.
Right,
or something
I
like
guess
that.
that's what I'm asking is, does anybody have any ideas on how to encourage something like that? Is it worth doing? Is it?
I know a few implementations, but again, they usually stop at whatever they need.
Right.
Right.
So they
exactly.
never go all the way because it's like, I do it for the needs I have. This slide rule that was mentioned is exactly that kind of situation.
Wasn't there an implementation by someone in Switzerland, I think also in Java? I don't remember who that was. You guys know anything about that? I thought there was some other Java implementation for reading something from HDF that was more complete than the Unidata one, I thought.
There's people who definitely try it.
Was there?
If they never contact the company or say, I mean, they can
Yeah,
read
no.
the spec and they can do it by themselves. There is no limitations. So
No, someone in the company.
no
knew
one
about this.
contacts and say, I need to be blessed or anything like that. So,
Sometimes people, we can tell if somebody's trying to do it because of the questions that they ask. They'll hassle the help desk or then they'll ask questions.
yes,
We can tell
right
that
now,
they're-
if someone is doing it in C# because he's asking questions in HDF forum about various parts of the HDF5 file format, and he's using C#. So, you know,
Yeah, I'd be happy if there were other implementations of it. Just to, I think that's a healthy part of the ecosystem is to have native implementations.
all right, we have a thank you from the chat land. All right, so that's that. I think when I said 73 Earth minutes, I actually was pretty close. We did 75 Earth minutes. And so we are reached the end. Thank you for coming. And yeah, as Dana said, GitHub is now the main place, issues or HDF forum, but email us, especially for this cloud optimized HDF5 files. I mean, it's the feedback of people who are trying to do various things that is really going to be valuable. We can't do everything and we can't reach everyone. And we'll build from that experience. All right, thank you.